Welcome to class number 21. In this class, I will explain a complex topology which consists BGP, OSPF area type NSSA, and redistribution. So this is the topology we will work on today. So there are OSPF area and there are some BGP connections, and we do the redistribution from connected routes and BGP to OSPF and vice versa from OSPF to BGP as well. So in the middle we have backbone area 0 where we have R1, R2 and R5. So we are running OSPF in the backbone on these interfaces. And there are two other areas connected to the backbone. One is area 1, which is a standard area, and another area 2, which is NSSA area. So we are running OSPF between R3 and R2. And in NSSA area 2, we are running OSPF between R5 and R6. Okay, so these are all the OSPF neighbors. Then we have from R1 to R4, we have a BGP session. And R4 has a connected network 10.04.0/24 where we have a PC4. So this is connected. And between R4 and R1 we have BGP. And when we look at the PC3, R3 has a connected network in which PC3 has an IP of 10.03.1. Similarly, on area 2 we have R6 has two links. One is going to R7 where we have BGP, and there is another directly connected PC6. So on R7 we have a connected network where we have the PC7 located 10.07.1. So the goal of this topology is to advertise all the PC networks and then advertise all the transit networks as well. So what is a transit network in this topology is normally transit network are like the networks between the routers. For suppose in this case the transit network in area 1 is 23.23.23.0/30. So there are no PCs in this network, but this is a network where it will connect the PC networks. So the PC network traffics go through this network. Okay, so that's why we call this as transit network. So in this topology, 23 is transit network, 12, 14, 15, 56, 67, all these are transit networks. They are just connecting all the routers, and whatever the communication goes between the PCs, they have to go through this transit network to reach the destinations. Okay, so we only running OSPF in area 1 between R3 and R2. So what we can do is to advertise this PC network, we will redistribute routes from connected to OSPF here, and here from R7 we will advertise about this network through BGP, and then R6 we are running BGP, right? So whatever the routes we learn from BGP, we will inject it to OSPF. Similarly, we inject this connected route to the OSPF as well. From R4 we will inject this network to here. So this is how we redistribute all the PC networks into BGP and OSPF, so that all the routers in the network will able to know how to reach all these networks. Similarly, we do the configurations for the transit networks as well. So in the end, from any PC, you should be able to ping any IP in this topology, including the transit networks as well. So let's go through the configurations to achieve this. So for the PCs, we have assigned the IPs and the respective gateways with the last IP 254 in that network. So let's see the R1 configuration. So R1 is in OSPF backbone area 0. So first I have configured the hostname, enable the routing services, and then I have assigned the IP addresses for each interface. So this is the basic configuration. From the routing configuration, we have two things. R1 is running OSPF. Also it is running BGP and has a neighborship with R4. So let's look into the OSPF. So R1 OSPF, this is the process ID. We can put anything. So I just took one. And the router ID, easily to identify, I kept it as 1.1.1. And where we are running the OSPF, on this interface and this interface. So I included the network statements for that. I'm not running OSPF here. Then I did redistribute connected command. So with this command, what I am doing is whatever the connected networks I have, I am injecting into the OSPF. So why I am doing this is this particular network which is on towards the R4, that is not in the OSPF. So by default it won't be added to the OSPF database. For that I am advertising this as a connected route. I'm redistributing this connected route into OSPF. Okay, and then I'm redistributing whatever the routes we are learning through BGP. So in this BGP session from R4 we will receive about information about this network 10.04.0. So once we receive that information, we want to send it to all the routers. So for that reason I am redistributing whatever the routes I learned from the BGP into OSPF. Okay, and next let's go to BGP configuration. So I took the autonomous system as 111 and I kept the router ID same. Then I'm doing redistribute connected. So whatever the routes I have connected, in this case these three, I am sending it through BGP. So this is especially useful for these two networks. So R4 by default know about this 14 network, but it does not know anything about 12 and 15. So I am advertising these two connected networks. Then I am redistributing whatever the R1 learns through OSPF process, internal and external routes. So internal routes means whatever the routes learned through the OSPF enabled interfaces on this particular OSPF topology. External means whatever the routes the OSPF got into the external, like in this case here, this is external. This network is also external. This network is also external. So whenever these routes learn through the redistribution into OSPF, those will be external routes. So whatever the external routes and whatever the internal routes R1 is learning through the OSPF process, we are sending those, we are adding those to the BGP so that R1 will inform about all these networks to R4 so that R4 will know how to reach all of these networks. Then I am establishing the neighborship with R4 as autonomous system 444 eBGP. So this is the configuration required on R1 in this topology. So in R2, after configuring the basic routing and interfaces, on R2 we are only running OSPF. So OSPF process ID, then the router ID, then we are running OSPF here and here only. That's it. So there is no redistribution or there is no any other protocol running on this R2. So this is the just basic configuration. So once we enable the OSPF here and here, so it should be able to learn the routes OSPF through here and it can able to forward it to backbone area. So this is a standard area, so there is no specific area type configuration. R3. Forgot to mention one thing about here in R2. So R2 is area border router. It is connecting two areas. So one side it is connecting to the backbone and another side it is connecting to area 1. R3. So coming to R3, it is only running OSPF on this particular interface. And in order, so we are not running this OSPF on this particular interface, so the option is we can redistribute the connected routes into OSPF as external routes. Okay, so this will become OE to OSPF external route. Okay, that's how we are advertising PC3 network into OSPF of R3. Then R3 will advertise it to R3, send that through LSA, and then R2 will forward it to all other routers in the same area through OSPF link state updates, link state advertisements. So in R4 configuration, so R4 is running BGP. So apart from the basic configurations, the BGP configuration is autonomous system 444 router ID. Then only network we want to advertise from R4 to R1 is about this PC4 network, so which is already connected network, so that we can use network command to inject that route, or you can do redistribute connected as well, anything is fine. But yeah, I'm using network statement here. And then the neighbor configuration, which is R1 14.14.1 with autonomous system of 111. On R5, so R5 will be only running OSPF, so it is connecting two areas, one side connecting to area 2 and another interface connecting to backbone area. So this is backbone area 15.15 in area 0, and area 2 we have 0.0.3, and this is NSSA area. This is not a standard area, so we need to specify that it is part of NSSA area 2, and default information originate command I am using here. This is to inject the default route. Why we need to inject the default route? Because NSSA area will not allow type 4 and type 5 external LSAs. So R6 will not know about any external OSPF external routes coming this way. So that's why we from R5 we inject the default route, so that R6 will receive a default route. It will use that route to send any packets to the OSPF external networks. R6. So R6 we have connected, this side we have BGP and another side we have OSPF. So on the OSPF configuration, so we need to specify the area type. So this is in the NSSA area, and to specify to run OSPF on this interface we are using the network command and area 2, and we are using redistribute connected. So this is for to redistribute this PC6 network. So this is a connected network we are injecting into OSPF. So in NSSA area, type 4 and 5 LSS not allowed. So what R6 will do is it will generate type 7 LSA to redistribute this connected routes as external routes into OSPF. Then redistribute BGP. So from R7 we will learn about 10070 network. It will send it through R6 using the BGP. So once R6 receives the route of PC7 network through BGP, we are redistributing it into OSPF as external. So this will also generate a type 7 LSA. So once the type 7 LSA reaches the R5, it will generate type 4 and 5 LSAs about these particular networks and distribute into the OSPF network, and they all will go to all the routers in the topology. So next configuration is BGP configuration. So in the BGP configuration of R6 we have router BGP 666, the autonomous system number and the router ID. And now what we are doing with BGP is whatever the routes R6 learning from the OSPF internal routes as well as the external routes, we are all sending them into the BGP, so that R7 will learn about all these routes in this topology through BGP. Okay, for that we are redistributing OSPF routes, and we are configuring the neighborship so that routing updates will go to here. So this command is to redistribute whatever the routes R6 learned through the OSPF process, we are injecting to the BGP, so that R7 will receive those routes via BGP. Okay. Next, R7 configuration. R7 is only running BGP, and the only network we are advertising using BGP is PC7 network, and we have neighborship with the R6. So this connected network will be advertised through the BGP to R6, and then we have here redistribute BGP under OSPF, so that it will go here and like this. So it will go all the way. So these are all the configuration we need to do is the topology. Okay, so the one thing to remember from previous classes is, so NSSA area is not allowing type 4 and 5 LSAs. Okay, so that's why we have default originate command here, so that we are injecting a default route. Okay, also whenever we advertise or redistribute routes into OSPF from connected routes and BGP into OSPF, it is R6 is generating type 7 LSAs, and once the type 7 LSA reaches the R5, it is forwarding that information in form of 4 and 5 LSAs, so that all other routers in this topology will learn about these networks. So once we do all those configurations, you should be able to ping from any PC to any IP, okay, including the transit networks. So every command in that configuration will be required. Even if you miss one configuration, some of the communications may not work. Okay, so build the similar topology and use the same configuration, then verify route tables on each router and see how the route being learned. Okay, just trace. For suppose R3 is learning about 10.0.7 network, see how it is learning. If it is learning through OSPF as external route or internal route. If it is external, how OSPF got that external route. So if you trace that path, you should be able to follow this path. So R7 advertised this network through BGP, and on R6 we have BGP to OSPF redistribution, so that the routes get into the OSPF as type 7 LSA. Then R5 generated the type 5 LSAs, then they reached all the way from R2 to here. So this is how you should trace for this particular network. So similarly on each router you should be able to trace how exactly the router is learning that route for any network in this topology. So you can use the command show IP route, show IP OSPF database, show IP BGP neighbor advertiser routes, received routes commands to verify that. So once you've done that and understand how exactly each route learned and what is the configuration making it work, then you can try to work on these two things. So currently we have this is standard area, means type 4 and 5 LSAs are also allowed into this area. But once you make it into the stub or totally stub, then it won't allow these LSAs, and you need to do some configuration changes to make the communications work in this topology. So try to play with the area type in the area 1, change it to stub, and see if everything is same as before. The routing tables are in. It will not be the same, and you need to do some configuration changes to make the communication work. Then also same for the when you change it to totally stub. Okay, that's all for this class.